Welcome back to my channel. This is Darian with Darian the Dev, and you guys are tuned in, believe it or not, for week 8 of our career progression bootcamp. So thank you guys for tuning in with me. I'm gonna just check in on my phone to make sure that the stream is good and the audio is good. Welcome back to my Yep. So if you guys don't know, or if you're new to the channel, sorry guys, it's a little bright in my background. I'm gonna try to control the light as best as I can. But if you guys are new to the channel, we talk about everything from tech, entrepreneurship, coding, and startups here on this channel. So if you guys are into that, make sure you like, share, and subscribe. It really helps me stay motivated to keep putting out this content for you guys. And so in this one, we're going to just go ahead and jump straight into it. I'm going to get ready to call our guest in just a second. Today, we're going to be talking about programming languages, and I'm going to share some updates from the project that I've been working on a side project. So it's a C# web API with a React front end, and I'm going to share some of the updates that I made. We talked about it last week a little bit, but I didn't actually show any code. So I'm going to show some code this week, show a little walkthrough of what I have so far, and then kind of discuss where I'm going in the coming weeks. And then I'll be showing you guys week to week, as we also give you updates on the curriculum and how it kind of ties into the side project. So yeah, if you guys have any questions or anything like that, make sure you leave them in the comment section down below, and I'll make sure I'll get back to you guys while we're on the stream. So if I don't see it right away, just give me a sec. I'll be on like multiple screens, and then I'll get back to you guys in the comment section. So I'm gonna go ahead and get ready to call La in so we can go ahead and get started. Make sure Describe call this on. Describe this too. Whoa. I need to. Sorry guys, one sec. I need to get all of my screens on and working. Let me see. Oh, there we go. Select all cameras. Okay.
Hello?
Hey, La, can you hear me?
I can hear you. Can you hear me?
Yeah, I can hear you. Perfect.
How you doing?
Perfect. I'm good. Is your camera on or no?
Yeah, my camera's on.
Okay. So let me see. I need to see if I can see you on the stream. I had to update the webcam software, and it's acting a little buggy on me. So I'm just trying to make sure. I don't know if are you watching it? Are you watching the stream right now, or?
I'm gonna set it up right now.
All right. Oh, no worries. You popped up.
Oh.
All right. Perfect. So let me just. Okay. Cool. So I will go ahead. So for me, I'm gonna have kind of a shorter presentation. I didn't end up going with any slides this week. I'm gonna just kind of touch back on top of some of the stuff I touched on last week, and then show some of the code, and then do like a quick demo and just talk about. I got like 3 main points basically I want to go over from the project from this week, and then yeah, I'll pass it over, and then I'll let you share your slides.
All right.
So let me window. Alright, so I'll come back here really quick and share my screen. that. And then alright, so I'm just gonna grab this over here. Okay, so this is gonna be a really quick demo because it's not like there's not a ton going on yet. But I want to show y'all kind of where I'm at. I have a video coming up about this. It's probably tomorrow or sometime this week, but we'll just do a quick walkthrough. So far, this is my my like homepage, landing page for my React front end in the project. So this is where our home button goes to. So I've got sign up, which is the sign up form. It looks terrible right now. And then I've got the login screen that has these two buttons. So I want to talk about how these buttons now link to components like this, because I know this could be basic depending on you know how far into React you guys are, but I know for me it was definitely a learning opportunity. So I want to share how I was able to render components, new components on a button click, and then yeah. And so right now we have this sign up form where if I open up my console. So if I refresh and if I try to sign up with some invalid credentials and I submit the request, I get a server error, which is good because that's what I'm actually throwing inside my app. So I'm gonna go over that with you guys, the error handling for this right now. And then if I correctly enter the login credentials, I get a response back with the token. So I want to talk about my plans going forward for like where do I go from here in the app. This is just kind of what I was working on this past week, and then some of the learning opportunities that I came across this week. So I only really have like 3 that I'm going to cover. So mine will be pretty short. So let me bring the code over. Alright, so the first thing I want to talk about is that button, those buttons that were linking right there. So I did a lot of research. I was trying to figure out how to render new components on a button click in React, and there's a few reasons why it sounds like you might want to do it a couple different ways. Conditional rendering was one that I came across a lot, but I didn't feel like I needed to really do conditional rendering because whenever I tried to make a variable for each like role, so a student and for a teacher login, it got a little wonky. It started rendering components at the same time without like going to a whole new component by itself. It would render them on top of each other, if that makes sense. So I just want to show how I ended up handling that. If I'm in the right component here, nope, it's this one. So what I ended up doing was using link to, and I believe you have to import link from React Router DOM. So I guess it's a React Router like tag that lets you do this. There is a difference between lowercase l and uppercase L when you write this. I don't think it'll work if you do lowercase l because I tried that. So basically we can just link to whatever the path is, whatever path renders our new component. And then we can see over here at my app.js where I actually have the routes actually declared. So teacher login renders a teacher login component over here in my app.js route. So I need to get more into how React Router really works And La, feel free to critique me right now because I know I'm in your domain, so you could definitely tell me your thoughts on me taking this approach, like creating my routes manually like this in my app.js file, and then over here in my login options using link to actually make my button render a new component. So did you have any like design thoughts on that?
No, I think it's fine. I'm sort of watching the videos a little bit of lag, but I think it's fine right now. For right now.
Okay.
I think as you move forward, then you probably want to refactor it and make it a little bit, encapsulate a bit more. But right now, it's fine.
Okay. Yeah, so I gotta get. I don't know. For anybody watching, I just don't know like best practice necessarily, but this does work in terms of button clicks and rendering and React, and then everything else works with just a regular on-click event, like you would expect in JavaScript. So that was the first thing I wanted to cover: rendering new components on a button click. The second thing I wanted to talk about is going to be over here in this other file. So if I go to my auth controller, we'll look at some C# code. Where are we? Here. So let me close some of these other files to make it a little easier to see. Okay, so here in my login route or my login method, in my auth controller in my C# API, one thing that I realized was that for some reason, and I don't have an exact reason, but one like lesson that I learned kind of the long/hard way this week was that I need to pass an object here like this. I need to actually pass an auth user here. And if we look at what an auth user actually is in my model, the only reason I created this auth user, which only has an email and a password, was so that I can pass it to this controller and basically satisfy my compiler. So what I'm saying is I previously had email and password as two strings that I was passing in over here to this method. And that was not working for some reason. Every time I would hit this area right here on a breakpoint, it would tell me that the object, this teacher object, was not set to an instance of an object. So it was almost like a null reference exception. So I didn't really understand why. But I noticed that my variables, when I would step through the debugger, my variables were not coming through from my request. But when I create this auth user model, and then I take the input from the user and we pass that in and basically create a auth user model with it or object with it, then that satisfied the compiler errors, and then the rest of the code was able to run. So it's literally the difference between passing just raw strings, string parameters, and then actually passing an object. So I tried this both ways. If anybody out there knows more than I do about that, feel free to let me know why that is, because there are other methods where I do pass strings like this. So I'm not really sure why this happened in this case. But that's just more for me to research. But I just thought that was interesting. If you're working on a C# web API and you're getting like null reference exceptions or something like that, but you're passing like string or int parameters or something like that, you might want to try creating a model and then setting the values that your user is passing to you to that model and see if that helps. Because this doesn't even exist in my database. This auth user, I'm not even storing this in the database. I'm not doing anything with this except using it to basically capture the values from the request and authenticate a user. So, authenticate and authorize a user. So, thought that was interesting. And then my last one is in this same file. My last tip for the week or lesson that I learned from the week is down here. So, these two methods work hand in hand. This get teacher from DB for login. So the login method up here, as you guys can see, actually calls get teacher from DB for login, and we were talking about this last week when I was talking about authorization authentication. So these work hand in hand, but I needed to address error handling. So basically, I had a situation where once this auth user was working and the null reference exception was gone, I had an issue where basically, as long as you provide an email and a password, it was going to give you a token in return. And what I mean is, it doesn't matter if the email and password were actually found in the database, as long as you could hit this route and you passed it the correct parameters, you would get an access token. So obviously, that's bad for our application. We don't want that. So I needed to write some error handling that basically said that only if the password and email that you gave us matches something that we found in our database, then that's when we want to give you the token. And then if not, we want to throw an error. So I was trying to figure out the best way to write my error handling logic. And so I realized that I wasn't going to end up writing it. I played around with some ways up here to try to write some try catches and throwing exceptions and things in the login method itself. But I realized that I didn't really have the values that I need to actually, write that error handling up here. So I decided to come down here in the get teacher from DB for login and write the error handling down here, so that basically if you don't make it through this method successfully, then you aren't logged in. And so what I ended up doing was actually rather simple, but it was basically just checking if the password that we receive here, which is essentially whatever the user sends over up here as the auth user, but whatever those values are, the email and the password, basically once we take the password and convert it, we're just doing some stuff for the encryption. This is all talked about last week in week 7 if you guys want to watch that. But basically we just take that password and check it against the teacher password. So we go to the database, and here, let me take this one step at a time. So we take your email, we take your password, convert your password, because all the passwords in the database are hashed. So we need to hash the raw string that we get and make sure that's the correct password. So once we run this SQL statement, we're going to get a teacher return from the database if we successfully match the credentials. So when we get this teacher back, we have all the information about this teacher. So we know what the teacher's password was in the database. So what we say is simply, if the password you gave us, once it gets converted, doesn't match the password we found in the database, then throw a new exception. Otherwise, you're authorized. And that's why we were getting that internal server error over in the browser. So basically, it was just about this tip was just about writing error handling, because I tried a lot of different ways. I tried try catch. I tried creating some booleans that I was going to say, well, if this happens, then this is true, or if this happens, then it's false, and blah, blah, blah. I was going to authenticate you based on that, but those were really all extra steps. They were all kind of taking me around the way, and this ended up getting the job done. Doesn't mean that I won't need to refactor. I probably don't want to just throw a random exception, because right now that this is a 500, so it throws a random like internal server error, which would look bad to a user. So definitely gonna want to go back, refactor, and send you to a better looking error page. But I just wanted to go over my process of doing that, so anybody out there, you can see that 3 lines of code, 4 lines of code was still enough to actually handle the error handling for logging in by checking the passwords. So hope that was helpful, y'all. I'm gonna go ahead and if you didn't have any questions, I'm gonna go ahead and swing your slides in.
Yeah, no, I don't have any questions.
All
right. Watching your video.
All right, got you. All right, bring this over. It's crazy that it's really been 8 weeks. It's really 2 months of straight studying.
Yeah.
So I got your slides up. It might be a little lag on the stream before you see them, but
Yeah, give me 2 seconds. I'm pulling up my notes too, so we both be on the same page.
Say it again.
I said I'm pulling up my notes as well, so
Oh,
give me
okay.
2 seconds.
All right.
Alrighty. Alright. Alright. So this week you can hear me?
Yep.
Alright, so this week I want to talk a little bit about programming languages. I guess, as we approach this 8-week part of our curriculum, I've been coding a lot more, and I've been coding a lot in a lot of different languages. So I thought it was really important that I sort of did some work on just understanding the purposes of these languages, what are the benefits, the pros or the cons, however you wish to view it, or what are the use cases or the best cases to problem solve. I don't think I'm fully done researching all the languages, but I will share with you guys what I have up until this point. So we'll move to the agenda.
Next slide.
And, yep, next slide. And so pretty much just going to talk about the purpose of the programming languages that I'm working with, the categories of these programming languages, and a review of a few of them. Well, actually the ones that I'm working with, per se. So we'll go to the next slide.
Mm-hmm.
So there's really four main types of languages when we talk about programming languages and how they're sort of organized for the system. At the lowest level, we have our machine language. And that language is any computer could understand that, understand its own machine's language. So all the hardware pieces, all the parts of that machine come with the language, and that computer can understand that language. So that's not to say that every computer from scratch with no software in it just has hardware in it, they can all understand the same language. No, I'm not saying that. What I'm saying is that all computers come with a set of hardware that creates the operating system, and that hardware has its own type of machine language that helps the computer understand what it is it needs to do. And typically that language consists of like zeros and ones, pretty much at that level. When we get to the next level, we're talking about our assembly language. That was pretty much because the machine language was built because it was slow and tedious. So wanted to make it a little bit more faster, a little bit more English-like per se, abbreviations. So the assembly language came next. Again, it's still a lower level language, so it's still not a language that we use, because it's still at that level. Some of it still uses zeros and ones, although we do have a few English-like abbreviations. However, that is the next step up from the machine language, sort of combination of machine language and what we're going to start to speak about next. The next level in this generation next level of this evolution became the high level languages. When you think about the assembly language and the machine languages, that was maybe the 70s or a little bit before the 70s. So computers were still being used the way we use them now. Programs were still being built. However, they were building these programs with binaries, like zeros and ones, machine and assembly language. So imagine how long and tedious it took people to build these languages. Like anything else you talk about in life, a business or whatever you want, you got to scale. In order for anything to become serious or legit in the world, it has to scale. So if computer science is going to become a branch or industry that can be profitable for the economy, it needed to scale. And the best way to scale it is to make it usable for regular people. And how do you do that? Well, the first way, you have to think about how we're communicating with it. If we're communicating with the computer with ones and zeros, there's no way that an ordinary person is going to want to take the time to sit down and figure out how to communicate with a program using ones and zeros to be able to turn it on or just write a low-level hello world language. So with that came the invention or the creation of the higher level languages. And those languages, again, like I said, they were created to add some speed to the programming process, right? So that you don't have to spend all day long coding these zeros and ones. You're able to code languages that other people can understand. It's easier to debug, and it's faster in general. So they started using single statements to use that, and compilers became important. A way of a compiler pretty much is a way of taking your high level language and translating that language into machine language so your machine can actually understand it. So that became important as well. Those languages, when we talk about the high level language, we're talking about basically our C, C#, C++, Java, somewhat Pascal, things like that. We're talking about those languages. Again, as we talk about scaling and moving on and making things a little bit more simpler for people, we have to, again, some might complain that Java or C or C++ or even C# for that matter, very verbose. It's a lot of syntax to understand. It's a lot of complexity to it. You can't just do what you want with it. So if you want to write a simple script or something small like that, I wouldn't necessarily think that C# or Java would be your best way to do that. So because of that, came the creation or the development of interpreters. And these languages pretty much they execute your high-level languages. So they're not even compiled. They're just ran as soon as you write them. Those are your languages you know of today, as like Ruby, Python, JavaScript, Bash. The shell language is also a scripting language. And those are those type of languages. So that's pretty much just the type of languages there are for a brief overview. So we go to the next slide.
Mm-hmm. There might be a lag.
No worries. So now we're moving to talking about the languages, and just a little brief overview of the different languages. Like I said, full confession, I'm in the middle of still studying and going through these things, so I'll speak to what I know, and there are some things that I do not know about these languages, or probably can use a little bit more education on, but I will explain to you what I do know about them. Bash language is a scripting language. It's a language that really talks to the computer itself. Is written for Unix. So a lot of Linux use it if you're dealing with DevOps or systems programming. You want to be able to use Bash. It helps you manipulate the computer system itself, your files and directories and things like that in a very quick way. Yeah, that's pretty much Bash. It's not built to be fast. It's just built to be able to write things quickly without having to, you got to think about Bash came out in the beginning before we had high-level languages. So if you just want to get something quickly written into a computer, you didn't want to have to write a big old programming language or a machine. You wanted to do it quickly. Bash was a good way of doing it. So we'll move on from Bash again. I just want to highlight that Bash is very important when we talk about systems programming because it definitely allows you to manipulate the systems a lot easier than other languages. The next language we have moving up from that line is C/C++. They're combined together because C++ is sort of an extension of C. C is pretty much your general purpose operating system languages. I would say almost all operating systems have some part of C in the programming of it. It's definitely your lowest level. It deals with the operating system a lot. And when we want to move away from the operating system, that's where C++ comes in. It adds different features to C that it didn't have. So it allows you to do your object-oriented things, allows you to do other things. I would just definitely think that C++, out of all the languages, are the most general-purpose languages. You can do the most with that language out of every other language that we have. And that language was developed in 1980. So again, 80 is far, but it's not really that far if you think about it. 1980 was the, last time, was when that language was developed. So we'll move on to SQL. SQL is very interesting because it's not really it is a language. It's a programming language per se, but it's a query language, so it's not like any other languages that we use. It's the whole purpose and function of SQL was just to manipulate data and store data in your database. So SQL is made up of two different type of languages: your data definition language and your data manipulation language. One of the DDL helps you define and structure how your information will be in your database, and your DML allows you to take the data out of it. So that's where you get your select star from statements and things like that. So it's just really important to understand that SQL is not really a programming language, but it is a query language. It's a language used for databases. So although you have all these other things, Postgres, etc., SQL is pretty much the basis of all that. And it's ironic if you think about it. There's nothing else has come out pretty much to compare to SQL per se. So we'll move to next. And the next language we have here that we're working on is Go. Go was created specifically for Google. So when we talk about these languages, it has purposes and reasons why they created. Here's the perfect one. It was created for Google to help with this sort of its concurrency issues. Google needed a lot of speed for its search engine and things like that. So they needed a language to help them focus on that. Go was mostly used for backends and web development. It's a compiled language and it's statically typed. It's very fast compared to the other programming languages, and that's because it has multi-threaded capacity and is really built for that. So that's pretty much Go as we look at it. The next language is Java. Java is a higher level language. It's definitely statically typed, meaning that you have to sort of define what your variables are before you program them, unlike other languages. Well, the scripted languages, you don't have to do that. It's compiled, Java, but it's compiled definitely differently than the other languages are compiled. And Java is interesting. It has like this 5-phase creation for their programming, how Java programs are created. And the five phases are edit, compile, load, verify, and execute. So, pretty much when you create your program in Java, it goes through all those phases before your program is actually executed. And when your program is executed in Java, it's executed in a virtual machine. So it's not executed on your actual operating machine. It's executed in a virtual machine. And that's why Java is the type of language that we talk about. You code once and you write anywhere, because mostly every computer uses the JVM on some capacity. So therefore, every computer has compatibility with Java. So when Java takes your languages, like I said, it compiles it and it turns it into bytecode that it understands, and it reads it through its Java virtual machine, and that's what makes it allow it to be able. And that through that virtual machine is where it communicates to the regular machine, and that's what allows Java to be portable, where you don't have to worry about writing to your specific machine language. You just write to Java, and Java will take care of the rest. And our next slide is Ruby. Ruby is an interpreted, scripted language, so you don't have to compile this code. So I definitely have to do more research and interpret it, but what I gather, because I think about Ruby, right? In Ruby, everything is an object, sort of like JavaScript, everything's an object. So if you really get down to the gritty of the language of Ruby and you look at the library, no different than when you look at the library of Java, the difference you'll see is that Ruby, like for Java, a lot of the primitive data types like arrays and strings and integers, they're just primitive data types. They don't have classes, they don't have libraries. They come with sort of the program, and they're like your most basic languages, most basic type. However, when you look at Ruby, everything in Ruby is an object. Even your integer, it's a class. It's an integer class called integer, and that's where your integer comes from. So when I look at that, it makes me think a lot that this language was built on top of another language, and everything was built as objects. It makes it easier for us to be able to manipulate it. So, because Ruby is not compiled like every other language. As soon as you code it, it's scripted, it's ran right away. And so for me, this is my assumption right now, is that the only way I think that could possibly happen, like I said, is that if you wrote this language on top of another language, so in essence, I'm not really writing to the compiler, I'm writing to that other language, and that other language is able to interpret what I wrote faster than it would be if I compiled it. That's pretty much how I look at it. I'll have to do a lot more research. I'm pretty sure it could be a lot more complex than me just saying it simply like that. But that's how I look at it right now.
Yeah, that's interesting.
We'll move to the last one, and the last language is JavaScript, and that language is developed and written especially for the web browser and the web browser only. It's fast, and the reason why JavaScript is so fast and so powerful is because it's written on top of the V8 engine, and the V8 engine is written C#. So I'm not C#, C++. So we just talked about C++ and how fast it is and how close it is to the operating system. And JavaScript is written right on top of that. And JavaScript is a scripting language, which means, like I said about Ruby, it's interpreted, which means that it's not compiled. So as soon as you write it, it's ran right then and there. And JavaScript, just like Ruby, is also, everything's an object. So everything is wrapped in an object, and you have your prototypes and different ways of commenting on things. So a lot of similarities, but there are some differences. JavaScript is fast. It does have concurrency, but it uses concurrency differently than Go does. Go uses threads for concurrency. JavaScript uses the event-based approach. They use that through their event queue. So that's pretty much that. I guess my topics to follow up on this comes for me is just that as I move forward with my operating systems, just to get a better understanding for myself of threads and concurrency, because all these languages definitely have a lot to do with threading and concurrency. And if you want to be able to write a program and make sure that you're getting the best bang for your buck when it comes to your language, and it's important to understand what the benefits and the pros and the cons are when it comes to that. I think garbage collection for me is important as well. I know it has something to do with memory and how a language cleans up unused variables, but I'm hearing a lot, or I've been reading a lot about how garbage collection, the benefit or the lack of benefit of it, it does affect how fast your program runs. So I do think it's important for me to understand more about garbage collection and what's actually happening there. But then the final thing I want to understand is just more about the Bash and the scripting languages. So I went over a little bit of it. But I'm pretty sure there's a lot more to it that makes it different. So I just want to understand a little bit better about why, what's the difference between the scripting and other languages. But yep, guys, that's pretty much all I had today.
For sure. Let me loop this back over. Where we at? All right, there we go. We're back. All right, cool. So yeah, that was good. That was like five different languages you've been diving in this week. So yeah, that's good. So for me, like I said, I got a video that's coming out for anybody watching on my next steps for next week. So I've already kind of done some upfront work, and then this whole next week for me is gonna be a lot of React studying, because I need to actually kind of figure out and research basically how I want to go about implementing my front end architecture for my components, because problem I was having was basically just ad hocing my way through it. So anytime I felt like I needed a new screen, that means I need a new component, and just throwing whatever data in whichever component with really no thought up front about it. And so, you know, Alon and I talked about that, and I'd rather kind of catch myself up front and take the time to kind of figure out what tools I need to use. And so we're thinking that maybe Redux might be something, because I have an application with a lot of data moving around and a lot of props to pass from component to component. So I think this week for me is going to be really researching how to move forward with my front end, because I'm way weaker at React than I am on the back end. So I need to really do a lot of research on that and kind of figure out how to implement my designs or my diagrams for my components that you guys are going to see in the video that's coming out probably either tomorrow or one day later this week, whenever I get it out. But yeah, and so La, I appreciate you for hopping on again with our 8th week, and we'll catch y'all here again next week for week number 9.
All right.
All right. See y'all.
Yep.
Peace.